Okay, so this is actually one of my favorite things in the world. It's like I love trig because of this thing. And so what we're going to learn today is called SOHCAHTOA, and we use SOHCAHTOA in right triangles to find missing lengths. But today all we're going to be doing is focusing on the ratio. And so again, like I said, the acronym is SOHCAHTOA, which we're going to write down at the bottom when we get there. But first we got to talk about the trig functions. So you guys might have noticed on your calculators, you have like these sine buttons, cosine buttons, and tangent buttons. And what they do is they find the ratios of a right besides legs and hypotenuse of a right triangle in relation to any given angle. And so sine is the first trig function we're going to learn. And so sine is technically spelled S-I-N-E, but we abbreviate it sin. And so sine theta says that the ratio of the angles using sine is going to be the opposite side over the hypotenuse. Okay? So in this triangle, we know that this is the hypotenuse, right? That is always the same thing. Hypotenuse is always the longest leg, but it's also always across from the right angle. So that is our hypotenuse. But the opposite side is in relation to wherever the angle is. So here my angle is here. So the opposite side is this side because this is opposite of the angle. So we're going to label this opposite. Cosine, which we shorten by cos, is the relationship of the adjacent side divided by the hypotenuse. Adjacent means next to. So we finish writing this adjacent and hypotenuse. So obviously, again, the hypotenuse is still this side, but the side adjacent to the angle is here. Because my angle is here, that's theta. It's a new symbol for us. But the side adjacent to it, next to it, is here. Now, tangent is the only one that doesn't use the hypotenuse. Tangent, we actually is the one we use most in the real life because usually we're not given the hypotenuse of our triangles. But here, the tangent is our opposite side over our adjacent side. So it's opposite divided by the adjacent. So this side divided by this side. So it's the ratio of the legs. Okay, and that is all of our trig functions. So we have sine, cosine, and tangent. So what we're going to do in our first example is we're just going to identify which trig ratio we can use. So here, if I look at my angle, which is right here, and identify the things that I have, this 5 is opposite of the angle. So I'm just going to label that the opposite, or OPP. And this 6 is adjacent to the angle, so ADJ. Now, which function uses opposite and adjacent? Well, that's tangent. Tangent use opposite and adjacent. So we would say tangent theta. We're not going to worry about finding the ratio. We're just going to say tangent is the one that we would use because, again, it has the opposite and the adjacent. Over here, we're going to do the same thing. I have theta, which is right here. 4 is across from it, so 4 is my opposite side. 9 is next to it, but it's also the hypotenuse of the triangle. So it's not the adjacent, it's the hypotenuse, or HYP. So here, I would want to know, well, to identify which trig function I use. Okay, well, I have my opposite, and I have my hypotenuse. Sine uses the opposite and hypotenuse, so we would say sine theta. And actually, we're going to box these so it's clear that those are our answers. Not that I'm just writing things next to it. Finally, obviously, we use tangent, sine. This one's probably going to be a cosine. That would be a good guess. So I look at my 8 first. It's across from the right angle. So this is my hypotenuse. The 6 is next to the angle. So this one is actually adjacent to it. And sure enough, the one that uses adjacent and hypotenuse is my cosine. So this is going to be cosine theta. Okay, so I just wanted us to practice being able to identify which one we use because this math is pretty easy, but it does require you to be able to kind of think first and be like, wait, which one am I going to use? Well, look at your triangle. What are you given? Which one is easier to use? So now we're going to do into some real examples. We're going to identify the ratios for each of the following using sine, cosine, and tangent. So here, I find it helpful to identify your sides first. It kind of helps you make less mistakes. So 17 is the hypotenuse. 15 is the opposite of my angle. It's across from the angle, so I'm going to label that my opposite. And then 8 is my adjacent because it's next to the angle. And I even just like kind of drawing an arrow over there to be like, oh, it's next to it. That's the adjacent. Okay. Oh, we got another adjacent right here. Forgot one. All right. So when I think about sine, remember, is opposite over hypotenuse. So O over H. So plugging in the numbers that represent sine, it's going to be 15 over my H, which is 17. So sine of theta is just the ratio of 15 over 17. Now I do cosine. Cosine is A over H, the adjacent over the H, over the hypotenuse. So here, my adjacent is 8, which means that it's going to be 8 over my hypotenuse, which is 17. So the adjacent ratio is 8 over 17. And then finally, tangent is opposite over adjacent. You know, I'm writing really small. It's because I got to fit a whole fraction in there. And so opposite over adjacent, that ratio is my opposite side, which is 15, over my adjacent, which is 8. And it would probably be helpful if I put the right numbers there, right? So 15 over 8. I just got really excited. So 15 over 8 is our tangent function. Okay? Moving on to the next one, I have my sides, so labeling them first. My hypotenuse, that's the one I always start with. Hypotenuse is square root of 73. My adjacent is the one next to the angle. So my adjacent in this case is 3. And then that means 8 is my opposite. It's across from the angle. So that's my opposite. So again, sine, remember, is opposite over hypotenuse. Sorry, I'm trying to think smarter, not harder. All right, opposite over hypotenuse. So in this case, the hypotenuse was square root of 73. We're not going to worry about proper notation right now. We're going to worry about kind of putting the thing right there. Technically, you can have a square root in the denominator, but we're just going to worry about writing down our ratio correctly right now. So sine is 8 over the square root of 73. That would be the ratio, opposite over hypotenuse. Cosine is adjacent over hypotenuse. Remember, A over H. Adjacent value is 3. Hypotenuse is square root of 73. So 3 over the square root of 73. And then finally, tangent is opposite over adjacent. So opposite over adjacent. So then 8 over my adjacent, which is 3. Notice that I'm leaving them as fractions. We like fractions now, okay? And that is how we're going to use trig functions and write trig ratios. Next, what we're going to learn about is actually using these to find missing sides. So we'll practice this a little bit. You guys will get really good, and then we'll find missing sides.